Pulse modulation is a technique to encode analog information into discrete pulse for transmission. It involves sampling analog signal in regular interval and quantizing each sample into digital format for transmission. Various techniques: pulse amplitude modulation, pulse position modulation, pulse width modulation. The major difference between PAM, PPM, and PWM lies in the parameter of a pulse carrier that vary according to the modulating signal. The pulse modulation parameter in PWM is the pulse width or duration. The constant parameter is pulse amplitude in accordance to analog signal amplitude. It encodes information by altering the pulse width in proportion to analog signal amplitude. In PPM, the varying is pulse position, constant is pulse amplitude. It encodes information by varying position of pulse, time interval indicating by the tau d, represented by analog signal amplitude. In PAM, the varying parameter is pulse amplitude and the constant is pulse width or duration. It samples the analog signal in regular intervals and quantizing into discrete level. Amplitude pulse is same as the amplitude of analog signal at the sampling instant. As in the arrow, pulse width modulation is the most immune to the noise. The pulse width in PWM indicated by the amplitude of the analog signal. Position of pulse in PPM is determined by analog signal amplitude. In PAM, the amplitude is changing to regular interval that are sampled. As pulse code modulation is not a modulation technique but method used to digitally represent analog signal. Three main steps: sample at regular interval, quantize into discrete level, and encode into binary code word. Pulse code modulation
is a process of transmitting multiple signals over a single communication channel. Through multiplexing, there is more information can be transmitted. Multiplexing is used to convert the digital or analog signals into a single composite signal. The medium used for multiplexing includes the fiber optic or radio wave. Quantization process is the converting of continuous analog signals to digital signals. In this process, each range is separated into quantized intervals with distinct digital code or level. The interval's quantity or quantization levels is expressed in bits, which is determined by the quantization resolution. For example, in a 3-bit quantizer, the formula of quantization is 2 power of 3 and the answer will be 8. So, there is 8 different levels that the sample values can be converted.
Sampling theorem, pairing increase and correlation increase determine a minimum sampling rate to readily reconstruct continuous signal without losing information. If the sampling rate is lesser than increased rate, aliasing happens. High frequency components are incorrectly interpreted as low frequency.
Talking about the digital audio, which is bit diff. Bit diff refers to the number of bits of information in each sample. It indicates the precision with which the amplitude of the audio signal is represented digitally. If the bit diff is higher, the digital system can capture and reproduce the original analog signal accurately. For example, in 16-bit audio system, each audio sample is represented using 16 bits of data. So the range of possible values for each sample is 2 power of 16, which equal to the 65,536 discrete amplitude levels. As a result, we get a higher bit diff that will allow for a more accurate analog waveform, reducing quantization noise, and also provide a better audio.
And I'm going to talk about multiplexing. Multiplexing is a way of sending multiple signals of information over the communication link at the same time. It is a process that takes place before modulation. There are few multiplexing techniques used in industries. The first one is frequency division multiplexing, which divides the communication link into subchannels of different frequency widths. The second one is wavelength division multiplexing, which consolidates and transmits channels using different light wavelengths. The third one is time division multiplexing, which transmits digital signals in alternating time slots. And the fourth one is code division multiplexing, which uses spreading codes to distinguish and encode signals.
And for the positive impact wise, of course, the first will be easier communication, where we are able to take use of telecommunication to connect a lot of people throughout the world. And next, of course, will be the economic growth, where enhancement of telecommunication able to stimulate the economic growth and promote digital transaction. And third will be the improved productivity, as a lot of communication and also advancement in technology able to speed up the internet and also increase the productivity. So I will be talking more about our negative impact of technology improvement. in telecommunication. First of all will be the invasion of privacy, where our privacy will be jeopardized by cybersecurity risks. And next, of course, will be environmental consequences, where a lot of electronic trash or e-waste able to produce through the development on telecommunication technologies. And next, of course, will be the unemployment issues in telecommunication, as a lot of automation and use of cutting-edge technology will cause employment displacement.
Now let's move on into recent advancement in communication fields, which is the 5G telecommunications. It is the 5th generation of wireless technology and has speed advancements, low latency, and also massive connectivity. For theories in modulation, 5G employs advanced modulation schemes such as QAN, which allows multiple bits to be transmitted in each symbol, increasing data rates. In multiplexing, it uses multiple access technologies for multiplexing, for example CDMA, which enables multiple users to transmit data in the same channel without interference. And the last one is in bandwidth. It utilizes wider frequency bands compared to the previous generations. It also gives benefits to revolutionizing industries. The first one is in healthcare. Patient care is improved with real-time remote consultations, enhanced telemedicine capabilities, and remote surgeries. In transportation, a faster and safer communication between vehicles, infrastructure, and pedestrians can be achieved. And the last one in manufacturing and Industry 4.0, automation and robotics will thrive with improved connectivity and the ability to connect with a large number of devices seamlessly.
So next I'm going to talk about the misconception, which is the telecommunication waves actually able to cause health issue. This actually is not being proven, as radio wave that transmitted through the network are using electromagnetic field radio frequency wave. And according to World Health Organization, actually extremely low frequency and radio frequency EMF are not able to cause any adverse health effect. So next we are coming towards the misconception to which is telecommunication technology entirely secure. It's actually not being proven, as right now there are a lot of cyber security threats inside our world, and it actually able to cause a lot of data stolen and compromise security in our cyber, so that actually the cyber criminals still have the potential to access to sensitive data and the disrupt system in our world.
As a conclusion, pulse modulation and multiplexing are important concepts in the field of telecommunication and signal processing. Pulse modulation is often used in the digital representation of analog signals for efficient transmission and storage, while multiplexing techniques will play a crucial role in optimizing the utilization of communication channels that will allow multiple signals to be transmitted simultaneously. The combination of pulse modulation and multiplexing is common in modern communication systems. It also provides an efficient and reliable transmission of information.